Good morning. My name is Nathan Schimpf and I'll be presenting to you today on WiMax. WiMax is short for Worldwide Interoperable Microwave Access, effectively a wireless medium to provide internet access. It could replace running DSL or fiber lines to each individual building, with consumers instead directly buying and installing a modem that could at will be added to the network. Now, this flexibility can add to some challenges, and it's compounded by the need for reliable communications in UHF, which is, as we mentioned before, a line-of-sight frequency band. On top of that, quality of service is required for providing internet access, this being where the needs of each user have to be prioritized. Because of these requirements, the WiMax standard has to address both resource flexibility and effective mitigation techniques in its physical and MAC layers. At the physical layer, reliability is the primary challenge addressed. WiMax was drafted based around orthogonal frequency division multiplexing, which is the definitive technique for most revisions of Wi-Fi. As an interesting fact, actually, Wi-Fi was originally tested for the use case of what WiMax now is, for providing wireless access to internet service providers. However, it ran into a couple of different issues that ended up making it not very viable, which led to the development of this whole standard for WiMax. So, getting back to OFDM though, it's an incredibly simple technique. This diagram over here kind of illustrates the whole process, where digital data is encoded in different techniques, and effectively it's treated as if it's one pulse amplitude message signal in the frequency domain. And with a little bit of filtering and an inverse fast Fourier transform, it's pretty much treated as just one signal that can be transmitted over the air. Demodulation process is equally straightforward in terms of performing a fast Fourier transform again and just reversing the various encoding techniques to map the symbols back to the pulse amplitude message signal, and then back from there to the actual binary digital data. In addition to that, OFDM simplicity kind of covers some of its estimation techniques and properties, especially in terms of attenuation and noise. Given a certain symbol rate, it can be estimated as what's called a flat fading channel, where a lot of the attenuation and the phase offsets that occur can be represented as more or less a linear equation or linear process. However, OFDM, as it was originally implemented, is limited by time division multiple access. When numbers of users are on a single cell, it really limits the amount of data that's able to get out to each individual user and effectively kills this whole need, or effectively kills the quality of service requirement. Because of this, the first revision of WiMax incorporated frequency division multiple access, which is where each user is assigned a subchannel. As a result, it can tailor the transmission to each user's needs. Modifying the modulation schemes for each user can balance the data rates against the readability of the signals, while allocating more or less power and setting up more complex spatial coding techniques can improve the signal-to-noise ratio both during downlink from base station to user and vice versa in uplink. Of course, this carries trade-offs, namely that increasing the power or modulation scheme complexity can add interference into the system, into the spectra that is, and it can also place a higher requirement for a higher signal to interference ratio on that specific channel. If the physical layer largely addresses reliability, the MAC layer primarily addresses quality of service challenges. It does this by incorporating feedback and frequent resource reallocation. Firstly, I should point out that all data exchange is strictly controlled by the base station, which decides when and how data is sent between it and subscribers. The transmission layout is fairly simple, with the same 4-stage frame used each time. The frame starts with management messages, which effectively declare what modulation schemes will be used by each subchannel, as well as when and on which bands each user should be listening and sending data. Following this is the downlink transmission data, and the frame ends with uplink data transmission, both of which follow the prescribed management messages. What I find most interesting and distinguishing about WiMax is the bandwidth request segment. During this, subscribers can provide feedback requesting more or less bandwidth to accommodate their needed data rates. This can be done by polling or contention, depending on the traffic within the cell. If the cell has a lot of traffic, the base station will poll subscribers or groups of subscribers to minimize the amount of time spent getting feedback. However, if there's lower traffic, the base station allows each subscriber to send their requests in a random order during that period. Finally, part of the uplink data includes subscriber acknowledgement. If there isn't an acknowledgement sent from the subscriber back to the base station, then the base station assumes data is lost and plays around with those physical layer trade-offs to compensate for any loss in data. So, in conclusion, there are a lot of design trade-offs that go into making WiMax viable, but it is absolutely possible. Between OFDMA enabling the higher throughput distribution in closer to real time for every device, to the careful encoding and budgeting that can be done at the physical layer to mitigate any sort of fading. And of course, finally, at the MAC layer, there is feedback mechanisms and control techniques to ensure that flexibility is provided with each frame per the needs of each user. In Kentucky, I found out as I was putting this presentation together, we actually have one small business that provides WiMax internet connections to roughly 4 counties. I found it interesting to see that this technology actually is being commercialized for, frankly, as little as I've heard about it before. With that, thank you for your time. If you have any questions, feel free to reach out.